Basically, my project is about Boid-Art. So using the Boid algorithm, which is pretty famous as one of the first historical agent-based model in artificial life. And my goal was to replicate images, giving them some graphic effect using Boids. So my inputs are basically two artistic techniques that are dripping and thread art. Dripping is quite famous because it's the technique of Polla. So just leaving color trails and forming some pattern on the sheet, while thread art is less known and consists in just passing a thread or a string over and over until you create a pattern and an image. So my idea was to take a reference image, which is the girl with the bird eating, and run some void simulations and trying to get a visual effect that is similar to dripping and thread art. We're more or less all familiar about Boid algorithm or its basics. So each Boid, which is a birdoid, so a bird-like object, follows three core rules that are separation, alignment, and cohesion. So separation means that each Boid tends to steer away from neighbors, while cohesion means exactly the opposite. So each Boid tends to go in the position of the average position of the neighbors. So these two rules are competing, while alignment means that the velocity of the void tends to align to average velocity of the neighbors. There is usually also associated a random movement in the simulations, but I prefer not to include it at this stage because I just wanted to test it. And also, it is important to define how do we define the neighborhood. Usually, there is one perception radius per rule, so one separation radius, one alignment, and one cohesion radius. It's common practice to take a separation radius that is slightly lower than the alignment of the cohesion one, which is biologically coherent to the fact that birds in a flock tend to steer away from close enough voids, while they tend to align and tend to move forward, like following farther away voids. I chose to limit number of parameters in my simulation, so in the one that I will show, I use just one perception radius, but of course the code can be easily can be easily changed. I also associated one color to each void. Each void will leave a color trail with a certain transparency, so allowing colors to mix, and each color presents a potential. So my idea was to add a fourth rule, which is gradient following. So I define a color potential and with a very simplistic definition of gradient, so the increment in the x and the y directions, the void will suffer a steer force in the direction where the color is more present. And of course, at the end, the final velocity at each step is given by a weighted sum of the fourth rule. So separation, alignment, cohesion, and gradient. I try to give much more importance to the gradient rule because I want to force the model to create an image. At the very beginning, actually, I was thinking of using some fluid dynamics to force the creation of the image, but maybe I thought that the potential idea was better suited. So in order to run the simulation, I need to create the potentials. So basically, I just took the basic shape of the girl outside from the background. I divided the color channels, and I also added a white potential, which will be explained in further slides. And I created an edge field considering the shape and all facial features such as eyes, nose, mouth, etc. I also gave them a Gaussian blur in order for the simulation and effect to be more natural and more smooth. And those are the parameters for one of the most complete simulations that I run. As you can see, I gave much more importance to the gradient, and I also gave a lot of importance to the separation rule rather than the others. This will be clear in a second, but basically what the separation does visually is allowing the voids to explore all the image space and cover all the regions. Another important thing is the number of voids inside of the simulation, because it has an effect also associated with the perception radius that I'm using. In particular, like just using few voids leads to a very slow simulation. So this is not sped up or slowed down, it's just how the simulation actually looks like. And also visually it's not really pleasing because I have these straight long lines that will of course impact the quality of the image that I will get. If I use more voids, of course, the space is going to fill up very quickly. Even though one thing that can be observed is that voids tend to stick in one region because of competition with other voids. And this might result into an issue as long as I do, for example, colored simulation, because that means that some regions will be too saturated with one color and will not accept other voids. Of course, in optimal, let's say, number of voids means that I have a more dynamic movement, also some flocking sometimes, and visually the effect is better. One also problem is the perception radius, because since I have the separation rule that is much more present, if I have too many voids and a too great perception radius, the voids will just vibrate like atoms inside of a solid. So I will just not produce anything at all. So why I chose to add a white channel rather than just using the black one for the black and white simulation, let's say. These are the two simulations compared. What happens is that just one color does the job. So I get the image more or less is still running. But what I get is that in the clear areas, it's full of stripes. So of course, this is coherent with my original inspo, which is thread art. But if this happens for just one color in colored simulation, it would be just a mess. Like the image would not be recognizable. So I decided to force the clear areas to remain clear by just adding one more color channel. This is, yeah, still far away. Okay. So this is like the colored simulation. I'm going to show it's a run of about 50 minutes. And so it's 80 continuous line. And like to get a general idea of the form, it takes like very few minutes. Like after 5 minutes, I get something that is fine. But in order to get nice details, I need longer simulations. What is, I think, like graphically appealing is that after the image is already formed, boards continue to move, and so they give this kind of animation effect that can be graphically interesting. And at that point, once I got this result, I just played with parameters in order to justify my choice of the separation weight. So if I just choose separation, alignment, cohesion to have equal weight, this is more or less what I will get. So basically I get a much more boring background because I don't have the colorful effect that I had before. I have regions that are inhabited by just one color and much more saturated, like the face is mostly yellow and this part is mostly blue. And much more problematic is that after this run is about 50 minutes, so the same time of before, this region is almost completely inhabited and uncovered. This is the reason why it's important to give importance to the separation rule, because it's the separation rule that pushes away the competing colors and tends to fill up this area basically. Then if I put importance to alignment, I get this kind of parallel lines that also have some kind of periodic movement. Visually might be interesting, but it's not what I was looking for, and also not producing something, I don't know, eye-pleasing, let's say. It's much more interesting what happened with the cohesion weight. Basically, the cohesion forces the voids to just collapse in this hyperdense object, and it's hypersaturated. So it creates these lines in the background that they become more present in a bit. And of course, like the image is not perfect, it's much more saturated, it doesn't cover everything, but it's interesting to know that we have also this tool that we can create these dense lines that create dynamics. One sec. Yeah, probably it's finished. Okay, so basically possible improvements are just using a personalized palette, so playing with the different areas of the image, but also paying more attention to facial features and details. For instance, as you can observe, in my best simulation, the eye is not really black, it's not really saturated at all. And this is because the face is an area in which white voids are more present than others. So there is a competition between white and black voids, and because I give so much importance to the separation, the probability of the black voids to enter is really low. while in other simulation, like where cohesion and alignment are more present, I can see that the eye is much more black. So like tuning all the parameters should be a key factor to get other kind of images. Of course, a better gradient definition would be helpful, and also adding new rules like random food predators and also reproduction. Like after this small project, I saw the effect of separation and cohesion. So it would be nice to create like a toolkit of which rule produce which effect and then just combining them. So it's more or less it. I thank you and hope it was nice.
Questions? I have a few questions. So you have these three channels, right? The three colors of the Boids. But are these colors kind of additive? So for example, if you put a yellow Boid, then a purple Boid, and then a cyan one, do you get the color which result of the combination of the three or not?
Visually,
yeah.
Yes.
Okay.
Because of the transparency.
Okay.
I just put 50%, so the effect is limited.
I see. Okay. So in a way, the colors are not mixing too much because
exactly. Like in fact, you can see that it's pretty much like the same color.
Yeah. Exactly.
But in some areas, like you can like see a little bit of green, a little bit of orange.
Okay.
I also did red, green, and blue. So
yes.
Of course, it's creepy. Like it's really bad the fact that it gives. So I didn't even put it in the presentation.
Okay, I see. Because with red, green, and blue, like each Boid would draw in a different kind of channel, right? So, so the color combined better or not? So that's not how it works.
I don't know. Basically, just each Boid leaves the color trail, and my idea of mixing was using the transparency. Like there is nothing else. So just every line is all the history of each Boid that they leave.
Okay. But in the example where you do red, green, and blue, since they can live in three completely different channels, so when you have a red line and the Boid goes with the green, it just adds on the green, not affecting the red, right? And becomes yellow.
It just
okay. Yeah, so I was wondering as well, what are the edge Boids doing? It's not clear to me.
Yeah. Basically, they are just black Boids that suffer of a different potential.
Okay.
Okay. So because I wanted like to give more importance to facial features and also on the general shape, and so I just extracted the features of the image, and since it's not just straight, it's like a Gaussian, the Boids anyway are attracted to this part and they move. In fact, in some simulation, you can just see, I think in the alignment, it's possible like they just do this.
Okay. Yeah. Okay, I see. But they're just black Boids as well.
They're black Boids, exactly. And they're also very few in number because I didn't want the effect to be
I see. But the Boids of any color interact together with the Boids rule as well.
Yeah.
Or not?
All the three rules are exactly the same. So in magenta and in cyan Boid, like they separate. They tend to separate, they tend to align, etc. They recognize each other. The only thing that changes is the potential that they suffer.
Okay. Another question I had is, so in this example, the color stays until another Boid passes on it, right? It does not decay.
Yeah, no.
Okay.
No.
Yeah, so maybe that would be something to try to kind of apply a constant decay to all the color channels, and that maybe also removes the need of the white Boids. So the white Boids puts white or erases the color. Okay. Yeah. Okay, I see. Interesting. I think I had one last question. No, I think that's it. Yeah. Any last questions? Okay. Thank you very much.
Thank you.
How long did it take to do like a simulation?
More or less, the good ones 1 hour, more or less.